Hey, what's up everybody? In this video tutorial, this is part 3 of Automata. So what we're going to be doing today is just basically putting the foundation, the base, the guts of Automata together. So you should have a screen that looks like my screen if you have followed parts 1 and 2 of our video tutorials so far. The only thing that you're probably maybe noticing that's a little bit different is that I do have an axle and I have a crank handle peg. So in case you did not catch that, here's all you have to do in order to create those. So if we want to create the axle, we can just simply come out here and create a sketch, go right here to the side, and then I'm just going to come out and project this edge right here. So if you remember back, we had a parameter loaded for that. So I'm just simply projecting that through. So if I say okay on that and finish the sketch, I can just simply extrude this out. Okay. So if you think about it, I mean, this is going to be the width of my box, and I'm going to add my plywood thickness plus another plywood thickness plus another plywood thickness. Okay, so we're talking about the width of the box, the shaft collar, another shaft collar, and the crank handle. They're all made of plywood, and they have that parameter loaded to them. So the only thing I'd have to do next is come out here and create a new component, say OK on this, and obviously we can pull this off. But then this is when I would come out, and I would just simply name this axle. And then within axle, I could come out, go into my physical material, and these are just simply using round dowels, so we would just drop pine onto it. All right, it's that simple to create the axle. For the crank handle peg, all we have to do is now come out here and create a sketch, and we can just go right here to the actual crank handle. This parameter was loaded, that's axle hole DIA, and I can come out and I could project this. And once again, that's going to be referencing that parameter, and all we have to do is use extrude. And then this is just an actual raw number. This is about 1¼ inches long. Oop, not taper angle, that's 0. But our distance is going to be 1.25, making sure we turn this into a new component, and now we can say OK. And then all we have to do is come down here to the end, okay, find that component name, and we can just call this our crank handle peg. All right, once again, this is made of round dowels, so we can come out, go into our physical material, and now we can use pine and just drop that right onto the actual peg and close out. All right, so that's it. That's the only real difference between what I was showing on my screen and your screen. So I'm going to go ahead and just get rid of those because I do have these already in my actual design. Okay, so now that that is done, okay, now we can go ahead and get moving on this. All right, so what we're going to do first is we're going to come out and use joint. I'm going to come and take a look at my axle end. So I'm going to come in, find the joint origin here at the axle end, and I'm going to take this to the joint origin here at the surface of this hole. So this is going to come in, but the problem is that right now, currently, under the motion tab, we can see that this is rigid. This thing needs to spin independently. Okay, so we can see that that's working. It's kind of hard to see this with the pine, but if you look close enough, you can see that seam that comes through, and you can see that that is actually moving. I'm going to jump back in here into position because we need a resting place for our shaft collar. And the shaft collar is going to be keeping this in place and keeping that axle from moving across our box. So I'm going to be using my offset arrow, and I'm going to pull it in this direction. And I'm going to say that this is going to be negative, in my case, PLY/THK. That's going to be a thickness of the plywood parts that we use, and that's already loaded in as a parameter, so we're good to go. Okay, so in order to test to see if this actually worked correctly, what I'm going to do is I'm going to come here to my joints, expand out, find my revolute, right click, and animate the model. And we can now see that that axle is actually spinning in place, and that's exactly what we want. All right, so we can see we have this nub on this end. That's where the shaft collar is going to go. On this end, we have a longer nub on this end. There's going to be a shaft collar and a crank handle. Okay, so let's go ahead and get our shaft collar on this end. So I'm going to come out, go into joint, go to my joint origin to the top of the hole, and I'm going to send this right over here to the top of the axle. When this comes in, all right, we can see a couple mistakes. Number one is it's actually spinning. Okay, so we don't want that to be a revolute. All right, but what we want that to do is actually be glued to the actual axle. In real life, this is not going to be glued to the side of the box. It's actually going to be glued to the axle. So I'm going to say this is going to be a rigid. We can see that that's shaking. Now I'm going to go back into position. For some reason, if this comes in and this is looking just out of sorts, try using your flip. Get that to go into position where this surface and this surface are flush. Now we can go ahead and say OK. So let's go ahead and check our work again by coming to Revolute. Let's right click and animate the model. The nice thing is the maple that we're using for our appearance, that grain, we can see that that is actually spinning in place, and that's exactly what we want. All right, so that's our first shaft collar. I want to be turning this over to the other side, and now I'm going to be going right into joint, going to the top of the hole, finding our joint origin, and taking this to the top of the axle. That's going to come into place. It's looking good. Just don't forget, you always have the flip in case that's coming in looking a little bit weird. The motion that we're wanting, once again, is going to be rigid. Okay, so we want to make sure that's a rigid. And now the position is we're going to use our offset arrow again. We're going to pull this back, and that's going to be worth, in my case, it's negative. It's going to be our plywood thickness. Okay, so that's going into place. Okay, we can see that that's going to be working great. We say OK, and now let's just check our work again by going to our Revolute and animating the model. So we can see that our axle, shaft collar 1 and shaft collar 2 are all spinning together working as one, and that's exactly what we want. So since we have our shaft collar in, our second one, now let's go ahead and put our crank handle peg in. So this is when we can go to joint. I'm going to come and place the joint origin at the top of the hole, and I'm going to take this to the top of the actual axle. That's going to come in. Don't forget, you always have the flip in case you need it. Now, for my case, it doesn't matter to me, but some cases, maybe some people want that crank handle to go straight up. You can always adjust your rotation, through the position tab in case you need it. Okay, I'm going to come here to motion, just verify that that's actually a rigid, and it is. I'm going to go ahead and say OK. And now once again, we're going to test our work by animating the model in Rev 11. All right, so we can see that that's all working together. So I can hit escape and get out of that. Now I can go ahead and throw in my crank handle peg. So I'm going to go to joint. Okay, using my joint origin like right here at the end of that peg. I'm going to take this right to the top of the hole. I'm going to pick on it. And now we can see this is definitely one of those cases that we can do the flip on it. So I'm going to do the flip. But the problem is that this is actually not going all the way down to the bottom. So I can use my offset arrow, push this down, and I can make this worth my plywood thickness. In my case, it's going to be a negative, and just verify that this is actually rigid. Okay, we're looking good. Now we can hit OK. And now we can once again test this by going to our Revolute, right-clicking, going to Animate Model, and we can see that that's all working together as that subassembly. All right, so we're all set and ready to go there. Okay, so the first thing I'm going to have you do if you're one of my students is go out and go into your snail cam. When you open up your snail cam, what I want you to do is go to Modify, go into Change Parameters, okay, and go ahead and bump this up to like a 5 or a 6 or whatever. If we can see that that increases, all right, you have a snail cam that works, all right? It's a true parametric. It's going to scale up. Now, unfortunately, the video tutorial that we're using, it's only going to allow you to size up. It's not going to allow you to size down. Let me demonstrate that. So if I come here to modify and I go into change parameters, and now I send this back to my 1.5 or where we started, this is the problem that we're going to see. So all you can do is, unfortunately, with our snail cam is you can only go up, you can't go down. So if that's the case, you can go ahead and you can undo this to get it back to where it was, modify, change the parameters, and now you can increase that. Okay, so for everything we're going to be doing with this automata, go ahead and set your expression to be 1.5 for the diameter. Okay, so once that's done, okay, now we can start dragging the cams that we're going to need into our project. Okay, so I'm just going to go ahead and drag in all 4 just so you can see me sort of work with the parametrics with this. So I'm going to go ahead and drag in my snail cam. I'm going to drag that off of the origin. I'm now going to come up here and find my pair cam, and I'm going to drag that off of the origin. Okay, I'm now going to drag in my eccentric cam, drag that off of the origin, and now I need my hexagon cam, so I can come down and find that, and here it is. I can drag that off the origin, so here's all 4 cams. Now, for your case and your design, you're probably going to have anywhere from 2 to 3 cams. Okay, so just drag in the cams that you need. Okay, so once you have them into your design, you have to make sure that they all have the nominal diameter of 1.5. So we're going to come down to all of our cams, and you're going to see that these were not built top down. These were bottom up because you're going to be seeing some different icons and these links. But if you need to check on these, all you have to do is hit the pencil. That's going to be bringing us where we're going to edit in place. Go into your modify, go into change parameters, and verify your diameter is 1.5. So we can see the snail cam is good, so now I can finish the edit in place. I'm now going to move down to my next cam, which would be our parametric pair cam. Go into modify, go into change parameters. I'm going to set this at 1.5, and it is. So I'm going to go ahead and say OK. But before, you know, I'm going to go ahead and finish the edit. I am going to change this. This does not look right according to what we put in this. So there it is. Let's drag it on there. Okay. All right. Moving down, going into eccentric cam. I'm going to edit this in place. Go into modify, change our parameters, make sure that this is 1.5 for my diameter. So I got that. So we're going to see if that's going to size up once I finish the edit. And then down here to my last one, which is hexagon cam. I'm going to edit this in place, go into change parameters, and make sure that this is set at 1.5. So all of our cams are going to be set at 1.5 because these are the actual diameters of the laser cut cams that I will provide to you. So now we're to the point where we can start inserting our cams. Okay, so in my case, I'm going to use eccentric and pair. We're going to keep this simple. Okay, so all you have to do is same thing once again. We're going to come right here to the top of the hole. Okay, and now I'm going to be moving this over and coming right here to the top of the cam itself. I'm sorry, top of the axle. If this is coming in, it's looking wonky, go ahead and hit the flip. And now you can mess with your rotation. So I'm going to say with my eccentric cam, this is going to be going straight up. Okay, so I have my rotation. Now I'm switching over to my front view. I can now find the arrow and I can pull this where the center of this cam is going to be lined up with the center of the rod guide. So this might take a little bit of tweaking. So I'm going to say I'm going to add 0.05 to it. It's going to get it right underneath it, and we do have to verify our motion is set at rigid. Make sure that axle and that cam are together, and it is. I'm going to say OK. All right, so we have our first cam in. The second cam we're going to be bringing in is going to be pair. Okay, so I'm going to go ahead and go to joint. Okay, go to the top of the hole, match that up with the end of our actual axle, that joint origin. That's going to come in. It's looking good, but I do want my lub going straight down on this one. Okay, so it's where it needs to be. Now I can look at the front of the view cube, use my offset arrow, send this guy over, and now I'm just going to back this off. In my case, it looks like it's going to be 385. Okay, look like it's dead center on it. Go into motion, make sure that this is rigid, and even check to make sure that that is actually attached to the axle. I can go ahead and say OK on that. Okay, so there's one thing that we have to take a look at. Okay, if we came out here, all right, and went in and animated our model for Revolute. Okay, we're going to be noticing the crank handle is going to be going one of two ways. All right, the one thing that you have to remember is that the only cam you're going to have an issue with rotation is going to be the snail cam. Snail cams only work in one direction. In real life, that snail cam is only going to be able to work in one direction. Now, Fusion's not as smart as we are in real life. It will actually allow it to work in both directions, but we can clearly see it's something that actually can't be done in real life. All right, so what I'm talking about with that is if you take a look at the snail cam, so if we take a look at snail cam, if we think about it, if the rotation of our crank handle is going to be in this direction, that means it's actually going to be locking up once it hits that follower rod or follower. All right, so we'd have to make sure that this is going to be reversed, okay, if it's going to be going, okay, in the counterclockwise rotation. All right, so this is the only orientation this cam would work in the clockwise rotation. All right, so just something to be thinking about. All right, so since I have the cams I'm needing in here, all right, here's the magic in all of it. You have to first make sure that you built your followers right, all right? So the actual profile, the bottom of this is going to be on this side. Okay, it should not be on this side because these things are going to be skipping right over the tops of the cams. Now, in order to get this to work, all we have to do is just pull down our followers, okay, get them close to those cams. And now all we have to do is come in. Underneath the symbol is something called tangent relationship. We pick the bottom of our follower, and then we pick the top of the cam, and you're going to see how it rests. And now we're going to be doing the same thing for the other side. So underneath the symbol, we're going to have tangent relationship, pick the bottom of the follower and the top of the cam. We'll see how it rests. And now what you're going to be able to do is is come out here, go into your joints, okay, go to your Revolute, animate the model, and now we're going to be able to see how these are going to work. Okay, there's a couple little things. When it comes to pair, when you're using tangent relationship, you cannot match the bottom of the follower with the peak of the pair. Instead, you're going to have to rotate it first, get to a large flat section like this, and then do your tangent relationship. On hexagon cams, what can happen sometimes is it can lock up. What you can do to make that work is remove the tangent relationship, update that hexagon cam with rounds on the actual corners, okay, and then go ahead and try the tangent relationship again, and it will work. Snail cams have a tendency to be very choppy, but they will work, so just kind of hang in there with the software. So there you go. That is our third and final tutorial on creating the guts, the foundation of Automata, and it's now going to be up to you to create the rest of this on whatever your scene is for the top of Automata. So there you go. Good luck.